I am Aikawa, and from here, I'll take you through the topic of video communication. Let me introduce you to the video streaming function. The demonstration will use a web sample application of video streaming now available on GitHub. First, let me show what you can do using this function. I have two Mac laptops here. One is for presentation purpose. I'm going to use the camera on this Mac. Another Mac here is connected to THETA S via USB connection. These will exchange the images on them with each other. This uses the web browser's WebRTC technology. WebRTC can handle webcam images so that web browsers can show them. To use WebRTC, information exchange is necessary, such as which IP address the other party is using and which encoding format is available. This is called signaling. This needs a server for mediating information exchange. This time we provide a mediation server free of charge to the DevCon registrants. The configuration is as in the slide. The RICOH server has an authentication function and protocol called BOSH. The authentication function controls who can use the service. I am repeating myself, but a protocol called BOSH is used. This protocol streams the XMPP protocol on top of HTTP. WebRTC often uses WebSockets in general. However, we have a BOSH service, and WebRTC can be implemented by using XMPP generally used for text chat and messaging. So this time we have used BOSH to implement WebRTC. We provide JavaScript code. We use open source modules, and we provide the sample JavaScript codes that handle WebRTC and BOSH protocols. A simple HTML page to be used as front-end and user interface has been made available as open source on GitHub. Now, let me show you a demo. The steps are explained on GitHub. Follow the steps to start a web server on this Mac or on a desktop PC. We are looking at the web server's page here. Now this page is opened in the Chrome browser. Chrome restricts that web pages capable of handling webcam images must be viewed on a web server machine itself. That's why today's demo is configured like this. Next, enter the username and password as explained earlier. Here's a key point. It's also explained in the slide. You'll get a RICOH Service User ID. It's basically your email address. Then, if you want to handle multiple users, it would be cumbersome to register multiple email addresses. Our service has a function to handle one email address for multiple users by suffixing it with plus something. In this example, when using the Mac's camera, I log in with the name suffixed with plus Mac. For a camera that needs a password to use, I will log in as a user of the FaceTime camera. Now, I connect to the RICOH server, making this system in standby mode. The lower right corner will show how you look on the other party's screen. Next, I'll explain the state of another Mac. On this Mac, the similar screen has already been opened, and the computer is connected to the server. This will use the THETA's images. So, I'm logging in with the name plus THETA. Here, enter the ID of the person you want to connect to. On the screen displayed, it has already been entered. Add plus THETA to create the connection destination user ID. Then press the Connect button. Before this, each Mac was independently connected to the server on the internet and was in standby mode. They now exchanged each other's IP address and other things via the server. Now, the images are being exchanged directly within this LAN. In a similar manner, this function easily enables real-time exchange of THETA images, today within a LAN, but even between remote locations. Plus, we added the THETA View button for demonstration. Please press this button. As you can see on the screen, this changes the view into an easier format to look at. Is this connected via USB? Is this shown with USB's 720 resolution? Yes, exactly. Can this use HDMI's resolution if connected via HDMI? It's changeable by the implementation in the web application. This demonstration and program use WebGL technology to make a sphere in 3D space using JavaScript on the browser. Inside the sphere, each semicircle of the fisheye image is pasted together. We're looking at the inside of the sphere from within on this screen, so to speak. Next, let me make a brief introduction to the steps to start the application we saw just now. The steps are simple. Get the source on GitHub using the git command. Then, you'll need the client credential as explained earlier. Copy config template in config.js and describe your configuration by editing it. Now you're ready to operate. Install with the npm command in node.js to handle the dependency and download the necessary libraries and others. Use the gulp command to build them together into one JavaScript module. Execute the run command, then the web server starts on your machine to open the page. This is the overall flow of how to install and start an application. As you have learned right now, you can use general tool commands to install the software. So I think even the first-time challenger may get an application running without too much trouble. These are general tools. In time of need, you may check on the internet to get information about them. Let me summarize my part of the presentation. This time, a signaling server is made available to you free of charge. A technology called WebRTC is realized by the Bosch protocol. As a key point, I explained about the user ID. By suffixing one registered user ID with a plus sign followed by different strings, the email address can be used for multiple users. And the Theta 360-like view we saw earlier. That is not completely the same as in theta360.com, but is in a simplified format. We have made available the source code to realize this easy-to-see view in a simplified format. I'm sure you'll find the code helpful. You may want to try out these functions or use them as a seed of ideas to come up with a function to provide a different use case. Just come up with a great idea to use, and the prize could be yours. My explanation so far may sound that Cloud API is just a communication thing. If you have any requests, for instance, if it can work in other ways, then you can use it for something interesting, please feel free to contact us through the GitHub Issues Forum. About the sample view shown earlier, can the image work with a smartphone attachment like a cardboard VR? I think there will be no specific problem if it's implemented in a web application so that it can work with cardboard VR. My question may be related to WebRTC. Other than exchanging camera images, is it possible to operate a remote device, say, operating the other Theta from this side? I'm talking about operation on camera accessory devices. That's a good question. We plan to provide the camera control function. WebRTC itself cannot do it. There will be an explanation later. We're thinking of making it possible to control the camera with a different function. Please look forward to the announcement. You have set up your own signaling server this time. Is my understanding correct that Cloud API for Theta can be used without it? Yes. Then it's no problem if I set up my own signaling server and use it, isn't it? It's no problem.